Hello programmers and welcome to a new video today. So in today's video, we're going to talk about binary search. We will understand how do we implement this search in searching items in an array, and we will write the Python code to this algorithm. So firstly, let's try to think about how do we find an element 13 in this array. So our task is to find this number 13. So if you have seen my previous video, I spoke about an algorithm called as linear search, which keeps checking each and every element in the list. So in this position, we need to find the element 13. So what we'll do is we'll create a pointer starting from the first element in the array. We will check, is that item equal to 13? Since 2 is not equal to 13, it will not be validate. Then we'll keep checking, and then we keep moving this pointer ahead, and in the end we will go at this position where we'll find the element 13 which matches our required element, and then we would return through. Okay, so we also learned that the time complexity of this algorithm is big O of n. Can we do something better than this? Can we reduce this method of finding an element in quicker time? Well, the answer is yes, and binary search provides the solution to this question. Okay, so what we do is we take an array, and we usually work on sorted arrays when it comes to binary search algorithm. Let's say we need to find this element 13. We will go at the middle of the element of the array, and we will search for the element. Okay, so now since there's 1, 2, 3, 4, 5, 6, 7, 8 elements in this array, just note that this is not the index. I'm just counting the number of elements in the array. Since there are 8 elements in this array, we'll go to its half position. Okay, so it will start from indexes. Okay, so I'll just write here index. The top portion is index, so it's 0, 1, 2, 3, 4, 5, 6, and 7. So what we'll do is we'll go to the fourth. Since the half of 8 is 4, we'll go to the fourth position in the index. Okay, and what we'll do is we will check. So the fourth position is 9. So we'll run a case saying that is the array at that mid position equal to the given item we need to search, and that is 13 that we need to search. And as we know, array of mid is 9 at this moment, and 9 is clearly not equal to 13. So there's one thing that you could realize in this array, that you can eliminate these set of items. Since our array will be sorted, the number 13 is never going to be present from the index 0 to n minus 1, where n is the value of the mid index. Okay, since 9 is obviously smaller than 13. Okay, so what we'll do is now we only need to focus on this array. Okay, this portion of the array, and the item is never going to be present in the left portion of the mid index. Okay, so what we'll do is we'll again draw our array. Let me find some space over here, and this time there's only going to be the elements ahead of that index. So there was 11, so there's going to be 11, 13, and 14. Okay, and you just ignore this empty space. So we're going to do the same thing again. We're going to search for the mid element in this array, and the mid element is 13. Okay, mid element is 13, and we just check whether that element is equal to the item we are searching, and yes, 13 is equal to 13, and then we return through since we have found the element in the array. Okay, and now let's try another example so that we understand this method in lucid method. So now let's try another example where the input array remains the same, but this time we need to find the element 4. So what we do is we again do the same method. We search for the element present at the mid position at the array, and this time the element is 9. Okay, so we'll just say array of mid is equal to 9. That's clearly visible. At the fourth position the element is 9. Now we will check, is array mid equal to the element that we are searching for. Is it equal to 4? Obviously no. Since it's not equal to 4, this time we do not need to check towards the right position, since the given element is smaller than the number present at the mid index. So obviously we can discard the set of numbers present which is greater than the number present at the mid position, and we need to check on the left position, since this time the number 4 is smaller than the number present at the mid index. So now we'll run the same thing again. So now the half of 4 elements in the array is 2. So we'll go at index 2. And here we go. The number present at index 2 is number 4, and that is equal to our element, and this time we will return true. So this is how the method works, where we run the binary search to keep on reducing the number of elements in our list that we search in. So we're keeping on halving the number of elements we search in. So if you see, we started on from this position, okay, 9, then we went to 4, and we just found an element. So in 2 steps, we found the number 4. Either if it would have been a linear search, we would have to do 1 step, 2 step, 3 step. Okay. And let's try to understand the previous sum that we solved. So now we've gone to the previous sum. To find the element 13 using the linear search, we have to go in 1 step, 2 step, 3 step, 4 step, 5 step, 6 step, and 7 steps. So basically in 7 steps we found the number 13. But had we done the binary search, we had to just go 1 step and from 1 to 2. So basically we just found the number 13 in 2 steps, then using 7 steps to find the number 13. Okay. So let's go to a compiler where we'll solve this problem. Okay. So I've created a function, binary search, that takes an array as an argument, an item that we need to search as another argument, and I've just passed it. So since I have to write the code now. So first thing is, what we do is, in this method, we first need to find the mid element. Okay. We need to find the mid element. So in this case it was 9. But how do we find this mid element? It's pretty simple. We need to find the length of the array, and we simply need to divide it by 2. Okay. We need to find the length of the array. In this case, the length of the array was 8, and we need to divide it by 2, and we'll get the mid. And that mid we'll be using to index to find the mid position. So how do we do that? We simply create these two variables. We'll say low is equal to 0, high is equal to len of array minus 1. So we just use minus 1 since the indexing starts from number 0. That is why we are using minus 1. And what we need to do is mid is equal to high divided by 2. Okay. So what happens is, right now I've done high divide by 2. So I'm just finding the mid element using the high variable, and I've divided by 2. But there's a problem in this line of code. So let's try to understand what is the issue. Every time we start finding the length of the array, we find from its relative aspect. So what does the relative aspect mean? At the first time while finding the length of the array, we were searching the whole array, okay? Finding the length of the whole array, and that was coming to 8, and then we were dividing by 2 to find the mid position. But the next time, we were only dealing with these 3 elements. That time, if we would have done the same formula, len of array, that is 8 divided by 2, would again take us to the same position 4. But this time the size of our array was 3. So we would have to do 3 divided by 2, which would equal to 1.5. And if you would use a ceil method, it would take us to 2. Okay, so that would take us to this index 2, I'd say here. Or if we just done minus 1, it would have taken us to this 1 position. Okay, so every time the length of our array keeps changing, since we are deducting the previous values present in them. Okay, so we need to find the low position also. Okay, so what we'll do is we'll add the low position and the mid position and the end position, and then we will find the mid value. Okay, so what I need to do is here, I need to say mid is equal to low plus high divided by 2. Okay, so every time we'll find the sum of the lowest index and with the high index, and then we will divide by 2. Okay, so now what I'll do is I'll create a while loop saying that while low is less than high. Okay, that is the number of times we need to keep this loop running while low is less than high. And instead of every time keeping on creating this mid variable and finding its calculation, I'll just put it inside the while loop. Okay, so every time we'll find the mid value that way. So mid is equal to low plus high divided by 2. Then what I'll do is, after creating the midpoint, we checked is the array at the mid position equal to the item that we want to search? Okay, so is array mid equal to the item? Okay, and the item is coming from this argument present over here. Okay, so we is the item array mid equal to the item? If it is, we just return mid. That is the index at which that item is present. Elif array mid is greater than the item. Okay, is greater than the item. That means the case in which, so now the array mid is 9 and the item say was 4. Okay, so 9 is greater than 4, which means we need to eliminate this portion of the list array and we only need to work on this position. So what we'll say is, if array mid is greater than item, mid is equal to I'll say high is equal to mid minus 1. So what is happening? Mid is 4 over here, so high is going to this position, and we are saying mid minus 1. So basically high goes to this position. Okay, so we'll work out high over here and low at this array position, that is this. Okay, okay, so what we were saying is, if item at the mid position is greater than the element that we are searching for, in this case is 4, we will say high is equal to mid minus 1. So mid minus 1 is obviously going to be at this index, so high will be here and low will be here. Understand? High is equal to mid minus 1, and this time elif the array at the mid position is less than the item. Okay, so it's just the other way around. So I'll explain you that also. Say we want to find the element 13. So basically array at mid is 9 is less than 13. We will move this low here. And this high will obviously be here only, since we are not working on that part. So low will get shifted towards the right position, and then we'll again find the mid element that way. Okay. So we'll say low is equal to mid plus 1. And this will keep performing while low is less than high. Okay, so basically now at this position also low is less than high, since the index of low is 0, 1, 2, 3, 4, 5, and the index of high is 6. 5 is basically less than 6, so this condition is going to work. But if you find some condition where high and low also point to the same index variable where 6 is, so it will become 6 is equal to 6, and then our condition will terminate. Okay, since we are saying low is less than high, so we'll do that. And then in the end, if after running this loop also and it ends, we do not find any item, that means the item is not present in the array. So we'll just return -1, or we'll say item not found. Item not found. Okay, so now let's just create an array and try running this out. Create a simple array 1, 2, 3, 4, 5, 6, 10, and let's say I want to find the check whether the item 8 is present in this array. Okay, so what I'll say is answer is equal to binary search. We are taking array as the argument, this array that we have created, and we want to search the number 8, so we'll just write 8, and now the answer will get saved in this variable answer, whatever output that comes, and we'll just print that out. So there's a number 7 come. Okay, so basically this number 7 means its index at which it's present. So let's check it out. Now 1 is present at the index 0, 2 is present at the index 1, and keeps going 2, 3, 4, 5, 6, 7. So basically 8 is present at the index 7, and that is perfect as the answer that we got. So this is how we solve the binary search. Now let's just check another test case where we put the number 11, which is, as you can see, not present in this array. So we just run this function and it says item not found. Okay, so what happened is it kept on checking, and then when this condition terminated, since low must have been greater than high, just got out of this while loop, and then it returned this statement, item not found. Okay, now we shall talk about the time complexity of this search algorithm. To understand the time complexity of the search algorithm, you need to understand the algorithm that works in this method. So what happens is, as at every iteration, I'd say every step, it works into halving the array, meaning dividing the array at its equal position into two parts. So at the first step, it divides the array. At step 1, it divides an array of n to n by 2. Okay. Then the next step, it divides that n by 2 array to n by 4. And then the next step, that n by 4 array would get divided to n by 8. Okay. This keeps going on. This dividing process keeps going on. In this array, it stopped since the size of the array was pretty small. But if you're working with a large number of items present in your array, this process keeps happening. So we'll see n gets divided by 2, n by 2, n by 4, n by 8, n by 16. And if you see something peculiar right now, it's getting divided in the terms of powers of 2. N upon 2 raised to 5, n upon 2 raised to 6, and this dividing keeps on happening. Okay. So now let's try to understand and take this term as n into 2 raised to k is equal to 1, since joining all these terms would result to 1. Okay. So what we do is, we just take n upon 2 raised to k is equal to 1, and now we'll just multiply it. N is equal to 2 raised to k, and then if you've learned the properties of log, you just do this log conversion, where log 2 raised to n base n is equal to k, where k is the number of times it's being divided, and in the end you get a variable n, and this variable n is joined to your time complexity. And let me find some space. So in the end, your time complexity sums up to something which is big O of n, big O of log to the base n. So in the end, your time complexity summarizes to big O to the log to the base 2n, which in the terms of computer science is just written as log n. Because whenever you're talking about log in computer science, you're always talking about log to the base 2n. So you do not need to write that down, but it's important to know how did this log value come. So it happens through this method. It keeps on dividing the numbers to half. Then we find an equation and we convert it using logarithm, and then we find its time complexity as big O of log n. So this is binary search. It is a great algorithm since it's quicker than the normal linear search, and it is great. It does steps so quick that it is highly recommendable to be used. But an important note to be taken down over here is the item or the array or list, whatever you're working on, must be sorted. Whatever you work on, the array must be sorted. It is a must requirement. Otherwise, this algorithm is pretty much not going to work, since we every time compare the mid value and check whether it is greater than the item we are searching or less than. So in the end, this array must be sorted. So that's it from today's video. If you do like this video, do drop a like, subscribe to my channel, and if you have any doubts, drop them down in the comment section and I'll help you out with them.